fun.
Same.
No, seriously, I hate it.
Same.
I hate it. No, can't. Because there's one concept that I have to give you guys. But I'm gonna surround it with fun stuff, hopefully. Well, it's not fun, it's a slog, but it's gonna be a fun slog. Because, you know, good times. How are you guys doing? How was the test?
Yeah, really.
Ah.
What do you think? How was the test?
I don't know. It's sitting in my office waiting to be graded. I have to take it home and drink a shit ton this weekend.
Oh, yeah. Hey, wait, you're gonna get drunk and grade our papers? I don't trust.
I don't drink when I grade the papers.
What?
I don't drink when I grade the papers. I don't drink when I grade the papers. Emphasis on, okay. Yeah, so, ha ha ha. No, I will be grading them this weekend, you guys. I had 3 classes take an exam on Monday and Tuesday, so I've got, like Memo saw it, it's a giant bag of paperwork that I have to grade, so that's my life this weekend. So you guys will get them back on Wednesday? You'll get them back on Monday? Cool. It should never be longer than a week for the test. The homework might be a little longer, but you guys know how much of the homework you did, right? You know if you did it all or not, right?
Will the results be
Yeah.
on Blackboard?
No, I'm gonna teach you how to calculate your own grade, because it's
Oh, you don't
college
post stuff
and
on
it's
Blackboard?
math. No,
You don't?
no,
Okay.
no.
Why not?
I'm gonna teach you how to do it your own damn self. It's math.
Well, yeah, but it's just nice to go on Blackboard and say, oh, this is.
That is nice, but this is a math class. Okay, all right. It is super nice, but no, I won't leave you guys hanging. I'm gonna talk you through the whole thing. All right, so sketchy curves, let's start with that. The first thing to remember, Yahoo, is my pens. If you plug an x into a function, what do you get out? A y. Oh, you guys sound so excited. If you plug an x into a derivative, what do you get out?
A slope.
A slope. If you plug an x into a second derivative, what do you get out? Concavity. Okay.
So wait, we're learning 3 things today?
Yeah. They're all tied together though. They all go together. So, concavity. Concavity is a really simple concept. Concave up looks like a happy face. And I demarcate it with a happy face with a little plus sign sitting inside of it because that's the sign of the answer. Concave down looks like a sad face. Seriously, don't overthink it, guys. So here's a function. Can you tell me, so here's x's and here's slopes. And then I'm gonna do another set here, x's and concavities. It's 10.1 and 10.2 combined. They're not like really tied together, sort of tied together. Can you tell me where the slopes equal 0 on this first guy? There. Okay, so this. Excuse me, dear God. Okay, so this x value, whatever it is, it's some value, right, has a slope of 0. Where else? There, right? So whatever that is, whatever that value of x is, has some slope of 0. What kind of slope is right here in this region? Growing or shrinking? It's growing, so that has a positive slope. What kind of slope is between those two x values?
Shrinking.
It's shrinking, so that has a negative slope. What kind of slope is out here?
Positive.
Positive. Okay, so now we've built a slope profile for this function. You guys with me? So talk to me about what I did. What did I do?
It's your bunch of pluses and minuses.
I did. First, I took the derivative, I set it equal to 0, and I found those two values. We call those critical values. A critical value is where stuff happens, right? Because it's critical to the function. I mean, these are important too, but they're not nearly as important as places where things change, right? Okay, so how do I test slopes in these regions? I have 3 regions, right? I found 2 critical values, which gives me a region to the left of the leftmost, one in the center, and a region to the right of the rightmost. I could just plug some test values from each of those regions into this derivative, and whatever the sign of the answer is, that's the sign of that entire region. Gesundheit. You guys with me?
Yeah.
Okay. I can do the same thing with concavity. Now, I don't want you to overthink it, but is that a sad face or a happy face? That's a sad face. Is that a sad face or a happy face? That's a happy face. So somewhere in there, it went from sad to happy, right? You guys with me? Somewhere around, oh, maybe right there. The second derivative equals 0. Okay? You look like you're gonna barf.
No, I'm just really confused.
Ah, don't worry, we'll do math. Showing you the visual first, then I'll give you the numbers. So this was a sad face, so I draw it like that. Not to be confused with the positive slopes. This is just a negative concavity. And this region had a positive concavity. Is everyone cool with that?
Yeah.
Okay, right? Okay. So we can use slope and concavity to determine things, right?
Yeah.
So what if I have a function that looks like this? Make it nice and good, just like that. And what if I told you to find the maximum? Before, you would take the derivative, set it equal to 0, and solve for x, right? That's what I taught you to do. But guess what? That won't give you the maximum if you have something like this. So we have 2 places where the slope is 0, right here, and right here. Which one's the absolute maximum, guys? The top one. What kind of concavity do you have there?
Negative.
Negative. Oh, it's concave down. So this is concavity. Conc. Okay? And there's a point, whoops, not there. Let's go through the places where the concavity is 0. This is basically a half of a sad face, right?
Yeah.
And this is a half of a happy face. So guess what? That same point, the second derivative is also 0. Jessica's like, oh, hell no. Did I lose you? A little bit. Imagine doing this with your hand. You're gonna make the shape. Anytime you make this shape, guys, that's sad. Anytime you make this shape, that's happy. So, sad, happy. Okay? Happy, sad. With me somehow? Okay, so we're just, it's like doing the wind thing out the window when you're driving. Yeah.
And is it all?
Happy, sappy, sappy, sad. God almighty. Okay, so it changed from concave down here to concave up here, but then it changed again somewhere around here. It went from concave up to concave down. So once again, we have another place where the concavity is 0 and then it goes concave down. So what's the profile for a true maximum? It has a slope of and a concavity that is negative. You guys with me? This is a false maximum. It has a slope of, which is like good so far, but it has a concavity that's also, okay? This is called a horizontal point of inflection. I'll spell it out. Horizontal point of inflection. So squeaky. Okay. Horizontal point of inflection. So the true max first derivative that's equal to 0, but a second derivative that's negative. Right? And HPI has a first derivative that's equal to 0 and a second derivative that's equal to 0. What about true minima? What's the profile for a real minimum? Slope is,
0.
concavity is positive. Okay, you guys with me? Where'd I lose you? Clara.
So wait, so.
I'm talking to Clara.
So,
It's okay.
I don't even know where you lost me.
Really?
Yeah.
Are you good with the first derivative equaling 0? Okay, so we're gonna take a derivative of the derivative, and I'm gonna show you.
Okay.
So hang tight.
I was just
Yeah.
gonna say, so you're like looking at the red points and then basing it off smiley faces or frowning faces?
Pretty much.
Okay.
Yeah, who knew that calculus would devolve into smiley faces and frowning faces, guys, but that's what it did. It just evolved.
So wait, is that what you're trying to,
That's what I'm trying to tell you, is it's
Okay.
that simple.
okay.
Okay, so let's do some math to show you what I'm talking about. You ready? You're like, no, I'm really not. This is not okay. Wait, I have an eraser now. So much better. Ah, yay.
Oh, so that middle part was just like that little half smiley face, that green point?
Yeah,
Okay,
it's a horizontal point of inflection.
okay.
And there's something called a vertical point of inflection, which is the point of diminishing returns, and we'll get to that hopefully by the end of class. All right. Now, let's do this real quick. Real quick. So quick. Hurry up. No, not that far. Do you guys talk to yourselves too?
Yeah,
So this is okay?
yeah.
Yeah. This is the judgment.
Really? I didn't give myself any notes for this because I hate it so much. I'm just gonna pick out problems because, you know, it's good times. Ooh, that one's pretty. I like that one. Y equals 1/3 x cubed minus x squared minus 3x plus 2. And I want you guys to find critical values for slope and concavity and then sketch. Because we can sketch it just based on those little thingies we did here. Which, by the way, positive slope, negative slope. Positive slope, negative slope. Check this out, guys. We can sketch our original function. I know I'm all over the map today. Bear with me.
How was the first part positive?
How was the first part positive? Right here? It's just positive slope, it's growing as we read from left to right. Okay, so I have a region that's positive slope and negative concavity, so it's kind of gonna look like that, right? Right? Up to that point where I have a 0 slope and 0 concavity. So I've maxed out at some point. Then I have positive slope and positive concavity, right? Up to this point, no, up to this point, this guy right here, where I change concavity to negative, but I still have a positive slope. To this point, where I have a 0 slope, and then negative slope, negative concavity. Is that kind of what it looked like?
Yeah.
Okay, so you can sketch these based on the slope and concavity profiles. Where I had this region up to here, this little region right here, and then this last region over here. Okay? Everyone cool with that? Groovy. Okay. So let's do the same thing over here. What's my first derivative?
X squared minus 2x minus 3.
Okay. What's my second derivative? Just do it again.
2x minus 2.
That wasn't so bad. Great. Chapter 9.8 is done. That was how to take the second derivative. So we're doing really 4 sections today. Great. Okay, so we're going to set this equal to 0. So critical values for slope come from the first derivative because that's where you go to get slope. 0 equals x squared minus 2x minus 3. What multiplies to negative 3 and adds to negative 2? 1 and negative, multiplies to negative 3? 1 and negative 3. So x plus 1, x minus 3. So I get x equals negative 1 and x equals 3. Those are my critical values for slope, which you guys already know how to do, right? Yeah, take the derivative, set it equal to 0, solve for x. Haley, why are you back there?
There was like no chairs on that side.
Oh, yeah, you're over there too. Oh, you guys all shifted. There are people here that aren't normally here.
But I think the desk was just moved around.
La la. Let's do the same thing, critical values for concavity. What do I do, guys? Yeah, set it equal to 0. 0 equals 2x minus 2, 2 equals 2x, x equals 1. Lovely. Okay, so far so good. I'll let you guys stare at that for a second. I thought it was awfully quiet today. There's a face missing back there. I kind of miss her. No, I do. She asks the questions you guys are all not gonna ask, but you're all thinking. Well, some of you are. Be brave. Who's gonna be my Caitlin today? Adam's always a Caitlin.
Ryan and I, the ginger team, will.
Aww. Okay, so I'm gonna build a slope profile and I'm gonna build a concavity profile.
Do we have to do this
Yes,
every time,
because I said so.
or just until we get good at it?
Just until you get good at it. It helps to have the visual. So slopes I'm gonna do in red. So I had 2 slope critical values. I had a slope of 0 at x equals negative 1, and I had a 0 slope at x equals 3, right? I had, in concavity, we'll do that in green, at x equals 1, I had a 0 concavity. So how many regions do we need to test for slope?
3,
Here, here, and here. How many regions do I need to test for concavity? 2. You guys with me?
Yeah.
Pick a number. So my test values, I'm going to say negative 2, 0, and 4. Why not, right? And over here, let's keep it simple. Let's make it 0 and 2. Anything in those regions works, right? So we're going to test slope. So what's y prime of negative 2? Well, that equals negative 2 quantity squared minus 2 times negative 2 minus 3 equals 4 minus 4 is 0. Minus 3 is negative 3. And all I care about is that sign, guys. Negative slope. So far, so groovy? No.
So these problems are pretty long, huh?
4 minus 4 plus 4. Oh, no, it's positive. Sorry, my bad, guys. Just make those positives. It's It's okay. 4 plus 4 minus 3 is 5. Thank you. Who said that? It's, hang on, don't tell me. Marco. I don't know where the Mick came from. I have somebody named McKinney. Is there a McKinney in here? McKinley? McKinney. Okay, never mind. All right. Well, he looks like you. But you're DeMarco. All right. Let's test 0. Y prime at 0 equals 0 squared minus 2 times 0 minus 3 equals what, guys? Negative 3. All we care about is the sign. So the entire region is negative. What's y prime of 4? 4 squared minus 2 times 4 minus 3 equals 16 minus 8 is 8 minus 3 is 5. Positive again. This is very fast, guys. I don't want you to overthink it.
Is there a quicker way?
Yes, it's called graphing it.
Oh,
But I want to see this
okay.
on your homework.
Got it.
Let's test concavity. So what were our 2 test values? 0 and 2. Keep these color coded. Okay. And so we're plugging them into the second derivative. Y double prime of 0 equals 2 times 0 minus 2 equals negative 2, concave down. So this entire region is concave down. Wow, it's a lot of color. That's kind of blinding, isn't it? What about 2? Y double prime of 2 equals 2 times 2 minus 2 equals, oh dear God, so many 2's. 2, positive, happy. Now we have enough information to sketch it. You ready? I'm gonna split this up into groups. You wanna take a picture before I just like rip this apart? So all you picture taking people. I'm gonna starfish against the nice cool wall. Cause it feels good.
Strike a nice pose, there you go.
Who's recording this? Oh God. Did you get the double chin in there?
You're out of angle, you're not in it.
Oh, goody. All right. So here's one region, includes slope and concavity. I just used my critical values to demarcate. Okay? So I have positive slope, negative concavity. This region looks like that. Everyone cool with that? Then I hit 0 slope, but still concave down. Now I have negative slope, negative concavity to this point. You guys with me? Then I have negative slope, positive concavity. So I'm still going down, but now I switch to concave up. All right? And at this point, I flatten out for my slope, and my last region is positive slope, positive concavity. Graph it. Graph your original function. Check my work. So hard. This should be on high. It should be pointing at me. And you. That's nice. Okay. So what was this original function? Just for giggles? 1/3 x cubed. Minus x squared. Minus 3x. Plus 2. If I wanted the actual y values, where would I go to get the y values corresponding to all of these critical values?
Original function.
original function, right? Because keep in mind, guys, that this profile could look like that, or it could look like this, right? Or it could look like this. Same profile, different y values, okay? So if you really want the full shebang, you'll want to get the corresponding y values to each of these spots. Okay, so that involves just a little more work, but it ain't too terribly difficult. I just said ain't. Wow. That's embarrassing.
Hey, I don't want to get up from there.
So to get those y values, would you put in all of them, both like for the slope and the compound?
Nah, you only need your critical values. Your critical values to get the y values.
Of slope or both of them?
Both.
Okay.
Because that'll tell you where it changes from concave down to concave up. Okay? So am I right? Does it look like this? Yeah, it does. Not bad, right? Yeah. But you can do it. It's just tedious. Prepare to spend a page on each of these problems. It's mostly graphing, you guys, relax. It's not that bad. Okay, I'm gonna erase this. It's not that bad. Sometimes you get something called a horizontal point of inflection. So let's just look at the slopes in that one. So let's say I get a slope profile that looks like this. So here's my slopes. Say I get some slope profile with these critical values. 0, 0 slope, 0 slope, 0 slope. And then I get positive, negative, negative. So I already showed you one of these on the board. So you can do this just with lines. Positive slope, 0 slope. Negative slope, 0 slope. Negative slope. Okay? So if I smooth that out, it's probably going to look like that. But we can confirm that with the second derivative, right? We can check our concavities to confirm where it's going to change from concave up to concave down.
Will it always curl up like that? Even if it's like no?
I suppose it could just go on forever, but in this section, I
Why
guess I
did
should
it
give you a,
Oh, yeah.
is that better?
Yeah, I was like, why are you going up now?
Because I told it to, and then I lied. So the last bit of this is that.
Is that a point?
Nah, it's just incomplete.
There.
You're already at like 4 points, dude.
Am I?
Yeah.
No, that's Ryan.
Oh,
He's
that's
up.
Ryan.
God damn
Sorry to get you-
Should I give him the point, you guys?
it. Yeah.
We got a fan group in the
Do I
back
get a
there.
Yeah.
point for getting us confused?
No. I already apologized profusely for that. Now you're just making it worse. Questions about this so far, guys? What's the hardest part gonna be for you?
The work.
The work?
It just.
The tediousness?
Yeah.
What else? Because everybody struggles with something. Where's your struggle spot?
I really like the visual part.
Do you like the visuals?
I don't
You
really.
don't? You just prefer the math?
Yeah.
Groovy. Okay. Wow, you guys are preferring the math?
We
Look
are.
at you little mathematicians. Damn, okay. Well, let's do some more of that then. La, 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 la. But first, another chart. another graph. This one matters, you guys. I want you to put this in big pink puffy letters. This will be on the final. And it will certainly be on your test too. Like, certainly. You're like, okay, we're waiting. Sorry, kids. Oh, what the hell? You can do it here. No, page 2. No. Okay. Yeah, I'm not gonna do that. Let's give it to you like this. Here's production, which is X. Nah, production's time. Sorry guys, when I make the sausage, I have to erase here and there. And this is production. So when we're doing productivity, usually the x-axis becomes time and the y-axis becomes production. So let's model a day. When you walk in at t equals 0, how much have you done at work? You've done nothing, right? So we start at 0, 0, okay? How many of you hit the ground like running when you get to perk? Or does it take you a few minutes to like gear up? It takes me a few minutes. I stall, I look at my email, surf Facebook, drink my coffee, go do the things you do. So as time goes on, you start to get into your groove, right? As time goes on further, you're like well in your groove. But then lunchtime hits. So you put your day on rest, right? So that break is like lunch. And then after that, you're kind of still in your groove, but now you're thinking about heading home for the day. So what happens over time? Well, the slope slows down. Very good, Ryan. You're still continuing to produce. This is still going up, right? But by the end of the day, say T equals 8 hours, you've capped out and you're ready to call it, right? The point where you go from concave up to concave down, that point, this point approximately right here, is called the point of diminishing returns. How many of you guys have heard that phrase before in your business classes?
Did you put that closed circle and replacing it with, or did you replace the little line slope thing with that closed circle?
I'm just giving it, this is the point right here.
Okay.
That's the point we care about. It's not a closed circle or an open circle, it's just a point.
Oh, just a point.
And this is the point where the second derivative of this function equals 0. So whatever this function is, if you take the derivative and set it equal to 0, or sorry, the second derivative and set it equal to 0, you're finding where it changed from concave up to concave down. You guys with me? Finding the point of diminishing returns is just that simple. Find the second derivative, set it equal to 0, solve for your x value, or t in this case.
Will the second derivative always just have one x value? Not
Usually,
Okay.
but sometimes there will be others, but you'll be presented some kind of range for t, And if they're outside of the range, that's not it,
Okay.
right? So this may have all kinds of other action going on. It may do stuff like this. But if we're going from 0 to 8, this is the only part you care about. Does that make sense?
Yeah.
Okay. All right. That kind of ties into what we're about to do in a bit. Actually, that was a great question. Why do we care about that point? How many of you want to make $1 million before you're 40? Go become efficiency experts. Businesses need them. They use them all the time. You guys ever heard of them? They're the ones that come in, they watch you work, they analyze your processes, they look at your corporate culture, they figure out what gets you to that steep slope, the steepest slope in your day. What factors create this really efficient productivity in the middle of the day? And then they try to extend it. They take that slope and they try to extend it even further so that your production goes up. Okay, so that your productivity increases. And they make a lot of money. They make a lot of money doing this. Because they can go contract out to a corporation, work for them for 6 months, rearrange everything, clear out. Sometimes it's brutal for the workers, but they make a lot of money doing that. So if you care about money and nothing else, that's the place for you. Okay? But a lot of times these efficiency experts, part of what they do is they fire a crap ton of people. So being on the other end of that isn't so fun. Just FYI. It's dog eat dog, guys. Not my style. But maybe it's yours. And that's okay. Doesn't make sense. All right. Where else can we apply this technique? How many of you are going into advertising? You good? Yeah, okay, groovy. So let's say you're paying for an advertising campaign, right? And you start to see your sales pick up because of this advertising campaign. And then at some point it starts to slow down. Your sales are still increasing overall, but it starts to slow down. That's your point of diminishing returns. That's when it's time to stop that ad campaign and start a new one, okay? Because that'll carry your sales along with it, okay? There's a point where people get tired of seeing the same ad I know if on the weekends when I'm watching football and I hear, what's his face? The angry guy. Okay, and he does the truck commercial. Does anybody know what I'm talking about? What's his name? He's so angry and I just want to smash his little face. What's his name? No, oh my God, no, this is a national campaign. It's trucks, it's not Dodge, it's Chevy, it's Chevy, I think. He's a cranky man, what?
Or is he an angry guy?
Yeah, he's an angry guy. He did Rescue Me, the fire show. Anyway, it doesn't matter. I want to smash his face. I get sick of listening to that same effing commercial time and time again. So there's a point where a commercial saturates the market and you're not going to get anything out of it, right? The first time I'm like, oh, I want to see what they have to say. The 5th time I see it, I'm over it, right? Saturation's already happened. What were you going to say, Sam?
I was gonna say, like, since I'm a marketing major, like, I can see a lot with, like, products. Since you have your growth, your maturity, then you have your decline. I can see how that would fit.
That's exactly what this is about, right?
Can you
So-
use a product, if you're putting out the same product throughout the year, everybody's gonna get sick and tired of seeing it.
Right, they want something new. They want something fresh. So once you start to see your sales slow of a particular product, it's time to replace it with a new one. So it's the exact same idea, the point of diminishing returns. In colloquial terms, we say throwing good money after bad. Okay? Or bad money after good. Which the hell is it? I don't even know. Anyway, it's that thing. It's you spent money, and now if you continue to spend money, you're wasting your dollars because you're not getting as much bang for your buck. That's the other colloquial we use. Bang for your buck. All right. Let's do one. It isn't pretty though. Is that okay? It's actually, yeah. it is. It's not super pretty. I really want to find a diminishing returns problem that's, like, I need a negative x cubed for it. But I'm not finding one, so I'm just gonna give
Is
it
there
up.
one in the homework section?
Yeah, there is, but I'm not gonna sign it because it's awful. How about I just do it on the board and I'll show you why it's awful? Does that work? You guys cool with that? So this is one that I used to assign people. You're welcome. I was just tired of doing it in my office 14 times. That's really what it's about. I'm just lazy. Here we go. Ads and sales, diminishing returns. Suppose that a company's daily sales volume, which is attributed to an advertising campaign, is given by S of t equals 3 over t plus 3 minus 18 over t plus 3 quantity squared plus 1. Okay, find the point of diminishing returns.
Do we need a full page for this?
Do I what?
Do we need a full page for this?
Probably. Let's get ready. Okay. Is it ready to take the derivative?
No,
I'm gonna make it pretty.
It's ugly.
It is ugly. So I'm gonna bring this up top and change the sign. And I'm gonna bring this up top and change the sign. And I still have that plus 1 there. You guys are gonna hate this. All right, I'm gonna do the derivative and the second derivative in different colors. So S prime is gonna be -3 junk to the -2 times the derivative of the inside. Plus 18 times 2 is 36. Junk to the -3rd times the derivative of the inside. And the 1, you killed it, killer. Gesundheit. So now I'm going to simplify this before I take the second derivative. Okay? What's -3 times 1? Yeah, so I'm just going to get rid of those 1s out back. Sounds like I killed him or something.
Are you just simplifying?
Yeah, I'm just simplifying. Okay. All right. Second derivative. S double prime. What's the derivative of this first guy? 6 junk to the -3, right? Okay, plus 108 or minus 108, because the sign will change. Junk to the -4th. Notice I left out dn. Why? dn is going to still be 1 when I do this, so I'm just going to leave it. So I'm skipping a step here. You guys cool with this? It's ugly, isn't it? Okay. All right, Gesundheit. So I'm going to take this and I'm going to rewrite it, but I'm going to set it equal to 0 before I do. So now I have 6 over t plus 3 quantity cubed minus 108 over t plus 3 quantity to the 4th. Is everyone okay with that?
Why'd you put it back to the fuzzy form?
What?
Why'd you put it back to that?
Well, 'cause then when I go
Because
on-
now I'm going to solve for t.
Oh, okay, okay.
So I'm going to bring
it's
this
zeros.
entire
Okay.
thing over. So now I have 108 over t plus 3 to the 4th equals 6 over t plus 3 cubed. You guys ready?
Is this of the second derivative?
This is still the second derivative. Yep. So now,
I have a question.
Yeah.
Why did you add from t plus 3 on the top, it's to the 3rd, and then on the bottom it's plus 4?
what? It's always t plus 3.
Oh, never mind. Just,
Yeah, okay. So now I'm gonna multiply both sides by t to the 3, or t plus 3 quantity to the 4th. I bet you guys weren't expecting that, were you? Kinda, maybe. Those cancel. How many of them cancel here? All but one. Okay? So I've got 3 of them on the denominator and 4 of them on the numerator. So I'm gonna get rid of all of the denominator ones and just all but one of the numerator ones. Okay? Autumn, where did I lose you? I saw that. This guy right here? Okay, let me show it a different way. Instead of t plus 3 to the 4th, I'm going to do t plus 3 cubed times t plus 3. That's the same as saying t plus 3 to the 4th, right? So now these cancel, leaving me just that. Is that an easier way to see it?
It's uptown, correct?
Oh yeah, it's uptown. Notice I'm being very careful, guys, about numerator and denominator here. Numerator, denominator, numerator, denominator.
So you're just choosing the one with the highest power.
Well, I'm essentially cross-multiplying here. But I'm only doing it on one side because I'm lazy. So now I have 108 equals 6 times t plus 3. Now I can divide both sides by 6 right away. I know you hate this, guys. Hang tight. But you wanted to see it. It's better than you having to do it, right? Right? Yeah. Okay, so it's 108 divided by 6. 448? No. For 118? 18. Awesome. Thank you. Okay, so now I have 18 equals t plus 3. 15 equals t. This is your point of diminishing returns. So what was t? Let's read the question one more time.
How do you know it's diminishing returns? Is it always the x value at the?
Because what was the steps to find the point of diminishing returns? Take the second derivative,
Oh, that's okay.
set it equal to 0,
Okay.
solve for x. And this is what you're taking with you to the final, guys. You're going to need this. So just hang tight to it, because I know you're going to forget about it. Okay. So we took the second derivative, we set it equal to 0, and we solved for t in this case. T was time in days. So how many days did it take to find the point of diminishing returns? To start throwing bad money after good? That's what it is, bad money after good. 15 days. It takes 15 days before it's time to start a new ad campaign. People have short memories now. Shorter attention spans. Not a lot of patience. That's right. I can't watch the videos you guys watch. They're like a split second and it moves on to the next frame. It's a split second, it moves on to the next. I'm just like, bleh. I like long frame shots, like 5-minute continual camera. Old auteur. Yeah, I can't do it. You guys make my brain hurt. When you hit your 40s, you're gonna be the same way. Yay! You're gonna be like those young kids. Messing up the world. No. Questions?
Wait, was that it?
Yeah.
Okay. I thought we had draw sketches. So this is just asking like the problem be like find the point of diminishing returns and that's it.
You guys wanted a word problem.
Okay. Did we? Yeah.
That was it.
Okay.
Yeah. So in my book, I think this is number 37 and 10.2. Yeah, it's number 37 and 10.2. So you guys can look this up too if you want. Number 37 and 10.2. So there's another concept I want to throw at you, and this one's not bad. So let me know if I can erase. You good? I know you're doing a lot of stuff all in one day. This is the last time I'm going to do this to you guys. Okay, this is the last combined day. unless I get really sick and something happens to me and I have to squish more days in further down the line, this is the last time I'm gonna do this to you.
So what was this from? Was this on 10.2?
That was 10.2.
Okay, now you're doing 10.3?
Basically, yeah. Kinda, sorta. But again, they're all tied together. They kind of go in one massive pile. And I'll circle back to second derivative as we go, but just know that it defines concavity. It defines, it helps you to define maximum and minimum. So remember, a true maximum has a slope of 0 and a concavity that is negative. And a true minimum has a slope that's 0 and a concavity that's positive. And it's kind of in the picture already, right? That looks like a maximum, doesn't it? And this looks like a minimum, doesn't it? So the picture itself should clue you in as to what you're looking at. God, I hate chapter 10. 10.3. If I give you a profit function that looks like this, and let's say break even is down here at 200 units produced. We have a false maximum at 900 units produced. And then out here at 1,800 units, not to scale, we have the true maximum profit. Right? So this is production X.
So is there a slight negative slope like after the 900?
After, no, it should just flatten out and then start up again. That's not intentional, sorry. And this is dollars. So our mathematical maximum profit is gonna be up here, right? It's gonna be up here. But what if your company can't make that many? What if your company, because of whatever reason, because of cost, because of warehouse size to store raw materials, because of, because of manufacturing size, you know, it takes too much space and too many people to make a certain amount of the thing, whatever it is that you're making. So say that you can't make 1,800, you can only make 1,500 units of the thing. Whatever the thing is, I don't know, get creative in your brains. Whatever makes you happy. You can only make 1,500 units of the thing. Is this maximum profit point really relevant to you? No, what is? Nah, nah. Not 1,500. So even though 1,800 is where you found the mathematical maximum, if you're limited by something that looks like this, guys, you hate those little rules, don't you? Now they're gonna come back to bite you. So if you're limited to at most 1,500 things, this is your realistic maximum profit. Which is not to be confused with your mathematical maximum profit. Does that make sense, guys? So say you walk through the process, Gesundheit, and you find x equals 900 and x equals 1,800, and you use the second derivative to verify that this is the mathematical maximum and not this one. But you see that that number is outside of the range that you were given by the statement of the problem. then this becomes your new maximum. This becomes your new X that delivers max profit, or the production level that yields maximum profit. Does that make sense? Yeah, the X that gives you max profit, the production level that yields maximum profit. You're gonna hear that phrase from me a lot on tests, especially. You guys saw it in the exam, didn't you? Find the production level that yields maximum revenue. I think we did one like that. Or find the production level that yields maximum profit. That's what that means. That's find the X value that's tied to maximum profit. Okay. So let's do one like that, just for giggles, because we still have 20 minutes. Unbelievable. La, 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 la. Oh, I can give you one. Oh, I'm so happy. It's in 10.3. I'm gonna draw a big fat dot on that. Oh, that makes me so happy. No, it's in 10.2. Okay, so let's do one like the kind of thing I just did on the board. Oh, here's number 36. You guys are gonna love this. Can I erase?
Yeah.
You guys are good? So first I'm gonna write down what they give us. A small business has weekly average costs in dollars, which looks like this, 100 over X plus 30 plus X over 10. Okay, where X is the number of units produced each week. X is units per week. So far, so groovy. All right. The competitive market price for this business's product is $46 per unit. So price is $46 per unit. Okay. If production is limited to 150 units per week, I'm gonna write that down. Limited to 150 units per week. Find the level of production that yields maximum profit. Find the level of production that yields maximum profit. Max profit. And find max profit. So let's engineer this. We need a profit function, don't we? What is profit? No, that's revenue. It is revenue minus cost. Profit is revenue minus cost. Do we have a revenue function? No, but can we build one? Sure. Revenue is price times quantity. So my revenue function is 46x. Is everyone cool with that? Okay. Do I have a cost function?
Yes.
No.
What?
I have an average cost function. Remember, average cost is cost per unit. So how do I get C by itself? What do I multiply by?
X.
X. So if I multiply by X all the way across, I'm gonna get cost. So C over X equals average cost. So my cost function is going to be 100 plus 30X plus X squared over 10. Is everyone okay with that? Yeah,
Yeah. Well, I did not follow that.
okay.
Oh, you're going fast.
I know, I'm sorry.
Okay, so start over?
We
No.
should just erase.
Or just back it
where
up
the,
just, yeah.
just
back
in the
it up.
red.
This, all the red?
Yeah.
Okay, so I look at what I'm asked to find. I'm asked to find stuff that has to do with profit. So I'm gonna need a profit function. How do I build profit?
Pretty much stop.
Good. So I'm building myself a roadmap here, guys. I don't have revenue, but can I build it?
Yeah.
Yeah, it's price times quantity. So I take my price and I multiply it by X to give myself a revenue. Price times quantity, price times X, price times X. Do I have a cost function? No, I have an average cost function, but I can do something to it to make it total cost. I multiply it by X.
Yeah, can you do it, step between the answer and that one?
Yeah,
That would be great.
sure.
Thank you.
Mhm.
So it's asking you for the price function.
So I'm saying cost over X equals 100 divided by X plus 30 plus X over 10. Because this is my average cost, right? Okay, I'm gonna multiply both sides by X. So what happens here? Those go away. And this, when I distribute 100X over X, becomes 100. But X times 30 becomes 30X. X times X over 10 becomes X squared over 10. Does that help, Autumn? Okay, great. Okay. Yeah,
I think I was just confused because I was not thinking about it that way. It's like cost divided by X.
average cost is literally cost per unit, like we do miles per gallon. We just don't think of that, we think of MPG, but it's really miles divided by gallons. Miles per gallon, cost per unit. Okay, so now let's build our profit function, shall we? Profit equals 46x minus 100 minus 30x minus X squared over 10. Why did all those signs change?
Because you have to distribute.
Yeah. I'm subtracting this whole thing, guys, and so all of my signs on cost are gonna change. So now I'm just gonna simplify this. 46x minus 30x, 16x minus 100 minus, and I'm gonna do 1/10 x squared. I'm just gonna drag that constant out front. I like it better there. But whatever floats your boat.
What are you doing to do that?
What?
What'd you do to?
What's the constant coefficient right here?
Oh,
So I just drag that constant coefficient, the whole thing out front. Just like the constant coefficient here is 16. Constant coefficient here is negative 1/10.
I'm so confused.
It's okay, go with it. If I have 4x over 3, is that the same as saying 4/3 x? That's why. Does that help? Come find me. Okay, so now what do? Now I have a profit function. So let's decompose this down into its parts. That sounded gross. Let's deconstruct it. Find the level of production, X, that yields max profit. So how many of you guys came and visited me during the test?
I did.
Yeah. Okay, and how many of you guys were like, I don't know where to find max profit? And did I draw you a little picture on your paper? I have a few nodding heads. What did I draw? This. Where's max profit? What's special about that spot? Slope is 0. So we're going to take the derivative, set it equal to 0, and solve for x. So what's marginal profit, guys? Set it equal to 0. Okay. Am I done?
You have to plug that back into the original.
Which original? I have a crap ton of them.
um,
This is why you have to label these guys. Don't just do the right-hand side. How many of you are writing just this and not P equals? Marginal profit equals. How many of you guys are forgetting that part? Don't forget it. Because you have a whole bunch of functions here. You need labels for all of them so you know which is what. You know what's plugged in where. So I've got x equals 80. Double check. Does it conform with my limit?
Yeah.
So we're good. So now I plug it into the what function? Price?
Or
The original.
Profit function. Because I want max profit, right? So where do I go to get profits?
Why?
Do I go to the cost function? Do I go to the price?
Profit.
Do I go to the revenue function? Do I go to the average cost function? Do I go to the profit function?
There you go.
See why these are important to label, so you know exactly where to go. So now I'm going to plug 80 into my profit function. I don't know what that was. 100. Oh, I can make that a 16, can't I? Because I simplified it. That's nice. Stands 80 minus 100 minus 10 times 80 squared equals, I have no idea what.
oh, so the second page is the profit.
80 times 10 is 800, 6 times 80 is 480. So this is 800 and 480 is 1280. No, I better not do that. I better not. I'll leave it to you guys. 540? Okay. So that's my weekly max profit. That's not so bad. That's after I pay myself, right? Because I own a small business, so I'm paying myself. And this is the money in my pocket after all my employees are paid too. So I'm paid and I get profit. Not so bad. I could live with that. Does it make sense? Have you guys been overthinking these? Don't do that. Okay, here's your handouts. We still have about 5 minutes. I'm gonna go this end, it's easier. 2, 4, 6, 7. 6, 7, here's the first one, Clara. And I'm giving you the second one right away as well. 3, 4, 5, 6, 7. So you guys can take a look at these. Asking you questions. We don't have a lot of time for questions. I feel really bad. 5, 7, 2, 6, 8. There's that one. And there's this one. Awesome. That's going to be these guys. You guys are 2, 4, 6, 7. 7. Are you serious? What's that?
You do?
4. You guys are terrible at this.
Optimized
6,
from
7. Ha ha.
Boring.
Thank you.
Yeah, she goes really fast, so we'll have to watch the video and make a lot of pauses. I understand all the steps, but the algebra just
What?
Oh no,
Yeah, there should be 2 handouts.
you guys will be
Okay.
starting from tomorrow?
Okay, yeah, I'll make sure to do that in a sec. So, your homework. Your homework.
I'll make sure I'm recording you, just watching.
Okay. I want you guys to do on 10.1. Number 11. Number 13. And productivity.
10.1.
Yeah, for 10.2, I would like you guys to do P's. Number 19. This one has the first and second derivatives already done for you and factored. You're welcome. So if you don't have the same addition as me, look for the one that has the first and second derivative already done and factored for you. Okay,
You have the 11.
yes, I do. Number 27, and I know you guys are gonna ask me about this one, but try to do it on your own anyway, because you're tight. Number 35, which is production, again. And then on 10.3, so we're only at 6 problems here, that's less than what you guys normally see. I want you to pick 2 each. And I don't care which ones you do, so make them the easiest ones you can find. Maximizing revenue, minimizing average cost, and maximizing profit. There's 3 sections of application problems. I want you to do 2 maximizing revenue, 2 minimizing average cost, and 2 maximizing profit, for a total of 12 problems. You guys can do that.